Welcome to this topic on navigation. This is for the Airbus A320 family. Navigation system. I don't know when the last time you had a class on navigation, but we're still going to be dealing with similar components necessary to gather data. And this is having to do with, of course, the aircraft being able to safely fly its course without any obstacles. And so gathering data from different probes and sensors and systems is a mandatory thing for an aircraft in order to accomplish that mission. So we're going to go into different systems. First, we're going to explain what is the navigation system. What are we talking about when we say navigation? It's seems obvious, but I want to be a little bit more detailed on what we're talking about when it comes to aircraft navigation. And just go into the different systems. In particular, we're going to be talking about the air data reference, inertial reference system that takes part in gathering air data and being able to sense just information from different sources in order to fly the aircraft safely. The other thing too, we're going to go over to different panels that are responsible for controlling the radio, controlling the frequencies. Okay, so this is for navigation facilities, obviously, but the radio frequencies. And so there's control of that. And just kind of go over into, again, the different components that we have involved in different aspects to navigation. So let's go ahead and get started with all of this. Okay, so what is the navigation system? Okay, what are we referring to? The navigation system is going to be involving different, I would say, aspects or angles to the flight of the aircraft. So, for example, just think about the axes again, and I'm not really so much referring to, pitch and roll and that kind of thing, as I am just putting the aircraft in a. I mean, you can still use the quadrant, okay, and the axes, the X and Y axes and Z axes, which is, your third dimension there. The way that we talk about flight controls, and the attitude of the plane, etc. Here I just want to bring that up because the aircraft is flying as level as it needs to, unless it's doing a climb or a turn and has to pitch or whatnot. But the whole idea here is that as the plane is flying, it needs to, know, okay, how far is it from the ground? What kind of terrain is underneath this aircraft when the aircraft is flying at 30,000 feet or as it's climbing? So it's not yet up to, close to 40,000 feet, but maybe it's just getting there. So now we're at 25,000 feet. So it's very important to know what the terrain is underneath and just being able to obviously clear any obstacles, any potential problems or potential obstacles that could hinder the aircraft from flying safely. So, we would have to know that. And also just the communications that we have with some, with air traffic control, for example. There's the, possibility of, as you well have heard in the news, of aircraft collisions. So we have aircraft with aircraft in flight. And so we're trying to avoid these things. And so we do have a system for that. And that's going to be your traffic collision avoidance system, your TCAS. And that's just going to be able to, basically identify a volume of airspace around that aircraft so that it's free and clear, what needs to not be there because that, plane needs to make sure it flies safely. So just kind of break down some of the navigation system components, if you will. When I say components, I really mean just kind of different categories of systems that make up the navigation system. So here we're talking about information that tells people where is the aircraft located in flight. Okay, so position of the aircraft. Number two is going to be helping the aircraft to land, okay, and also in taxiing. And then your air data inertial reference system. And then, of course, again, just to mention about the position of the aircraft, positioning is going to be involving different computers and whatnot. So just to kind of reiterate here, you have position of the aircraft, you have systems to help the plane land, And then you have air data inertial reference system. Okay, so let's kind of break this down a little bit. Your air data inertial reference system, we're going to cover different things with this. This is with the attitude of the plane, also just being able to control the aiders through switching, and just there's a lot of different things there we're going to get a little bit more into than other equipment. But here with this one, with this system, you have units, and you also have a standby system. Okay, so air data inertial reference units are, make up this air data inertial reference system along with the standby system. And so it's basically going to be gathering air data. Okay, that's what's called air data. Okay, and then it's gathering that data and also taking the data of what the attitude is, heading in the position of the aircraft. Now, what about landing? Okay, so with this, you've got a receiver, and that's part of the navigation system. There's actually two. There's the ILS, which is your instrument landing system, and you also have your GPS, right? Your global positioning. So your ILS functions are there to get kind of indicate any deviation signals. This is going to be in relation to the radio beam, and then of course your GPS is a tracking thing. You're getting your position and tracking in your speed. Air traffic control, your ATC, obviously allows the operator of the equipment on the ground to locate and identify the aircraft in flight. That's what it's there for. Your VOR, your VHF omni-range or omnidirectional range, either way. This is basically what this does. It enables the bearings of one or two of the transmitter stations to be indicated with respect to the aircraft heading. But not just that, because you can have that with the directional finder, but in addition to that, you have also the indication of aircraft course deviation with respect to a pre-selected course. So it's just how, in relation to what. So there's two things that it's in relation to what, to what exactly. Well, number one will be the aircraft heading, and number two, a pre-selected course. And that's for the VHF Omni range. Whereas with the automatic direction finder, you have this as well, but you don't have the second part. So you have bearings of the ADF ground transmitter stations to be indicated with respect to the aircraft heading, and that's it. You also have a weather radar system. Okay, that's going to detect the position and the intensity of precipitations and the terrain mapping information. So weather radar systems there. You also have a radio altimeter. That's to determine the height of the aircraft from 0 to 2,500 feet above the ground. Okay, so let me just kind of run through these again. Okay, so when we talk about the navigation system, we can break it up into some parts. Okay, some aspects to how we want to identify the aircraft and its behavior and position, etc., kind of its state, if you will. That would be number one, position of the aircraft. Two is landing. There's systems to help. Is that multi-mode receiver? Okay, that's a navigation system there to help with the plane in landing. And then you have your air data inertial reference system, your ADERS. That's again gathering main air data and also your initial reference air data, okay, to help with navigation. The traffic collision avoidance, your TCAS, is to protect that volume airspace around the aircraft. And then you also have your ground proximity warning system, because when the aircraft is getting too close to ground, there's going to be a warning system in place for that. Okay, and then you have also, and I didn't cover it a bit ago, but distance measuring equipment, your DME. That's going to provide the distance that's separating the aircraft from one or two of the stations being received. Okay, and there's going to be a display on the navigational displays. Okay, that will show that. Okay, so that kind of gives you an idea with the different equipment that we have. So kind of think of this, we got your ADF, okay, that's your automatic direction finder. Your ATC, that's for air traffic control. Your DME, with your distance measuring equipment. Your EGPWS, which is your enhanced global positioning warning system, or excuse me, ground proximity warning system. Your TCAS, okay, that's your traffic collision avoidance system. Your radio altimeter, and that's to measure the height of the aircraft from 0 to 2,500 feet from the ground. And you got your weather radar, okay, that's going to be there to detect the position and also the intensity of precipitation and terrain mapping information. And of course you have units. On the ADER, remember I said the ADERs, okay, your reference system, there are 3 units, okay, there are 3 air data initial reference units that comprise the initial reference system. And we'll get into that, but I'm sharing a little prematurely, but I'm just sharing with you that there are 3 units that comprise that. Then you have your ILS, MMR, your multi-mode receiver. Okay, that's your multi-mode receiver for landing, and your instrument landing system, your ILS. Okay, so those are the different components, equipment that make up the navigation system. Now, there is tuning of radio. Okay, so you've got 3 means of tuning the navigation radios: automatic, of course, manual, and your standby or heavy backup tuning. So, yeah, obviously auto tuning is the primary one for tuning the navigation radios. And you have also the FMGC, if you recall from the flight controls topic that you may or may not have taken yet, but the management and guidance computers tune the VOR and the DME, ILS, and the ADF. Okay, in auto tuning, so auto tuning is primarily that. The guidance computer tunes the VOR, the DME, ILS, and ADF. Okay, in auto tuning, the radio management panel, which I'll get a little bit more into, but the radio management panel is there, and that is associated to associated with an FMGC. Okay, one of the FMGCs, relatively speaking. So basically, what's going to happen is, in case you have a failure of, either one, then you're going to obviously have a backup with the other FMGC computer. Now, manual tuning, that's the second thing. So if automatic fails, you can always go to manual tuning. Obviously, that's going to allow the pilot to manipulate that and use the MICDO to select what he wants on frequency. You also have a standby or backup tuning. So with we're going to look at that's going to be on the radio management panel. There are 2 radio management panels on the Airbus, okay, as part of the navigation system. So radio management panels, those are located on the pedestal, and there's 2 of them, radio panel 1 and 2. Those are on the pedestal, and they're just a backup means of tuning the navigation radios. Okay, it's a backup mode in case you have a failure of both computers, which would be a rarity, but things can happen. So, but if for some reason both of them fail, you have this backup tuning available. Okay, so what can you see on the panel? What can you expect? Okay, because you got different buttons on there. You can choose for your VHF 1 and 2 and 3, and also for your high frequency 1 and 2. So you'll see them on there when you get in the Airbus cockpit, but that it's pretty clearly labeled, I should say. Okay, so for the radio management panel, this is going to be controlling the communication frequencies, right? Okay, that's what it's for. It's also used for standby selection of the frequencies, again, in case you have failure of the computers. So you have that. Now, there is a power supply to the radio management panel. And just so you know, normally that power supply or the switch for it that's on and off is normally in the on position. Okay, that's the normal position. It's in the normal position. So you know that. So what's going to happen here? Okay, let's do some things here. All right, so there's a guard, by the way, on the on nav switch. So just lift up the guard and you press the switch. Okay, so what happens when you do that? There's going to be a light indicator. So that on nav key, if it's in standby nav, then the windows will continue to display the frequencies. And of course, you can press the VOR, ILS, or ADF keys. That's going to change the display, obviously, on there, so accordingly. And then you also have two knobs. Those are used to select the frequencies for your navigation and your controls, or excuse me, your communication, and that's in standby. Okay, those are for in standby. You can also select for VORs and runway heading for the ILSs. Okay, there's also a transfer key. So I'm going to give you an idea of what buttons to expect on this radio management panel. Your standby, it's STBY CRS, and then you also have your transfer key. Okay, so if you wanted to set, in the standby course window, and you can make active that by pressing the transfer key because it goes to standby CRS window. Okay, and then of course you have MLS, that's your microwave landing system. That's just a provision only. BFO, in case you see that, it is a key. Okay, B as in boy, F Frank, O Oscar. BFO is beat frequency oscillator. That's what it stands for. Beat frequency oscillator. And that's set on on or off, when you press the BFO key. I'll just toggle back and forth. Okay, and then so that's your radio management panel. You also, of course, have the other panels, and the one that you want to be more interested in, which you're familiar with already, but your MICDUs, where you can get some troubleshooting data on what's happening there. So MICDU. So we have that, your multipurpose control and display unit. That's going to be on the RAD nav page, and that's there to align the reference systems. Okay, through the computers, and that's going to do that from the initial page. And that's going to be your INIT abbreviation, by the way, but that's your initial page to initiate the test. Okay, so you're initiating those, and then it's doing that for troubleshooting. So, and then you also have your central or control and display unit. That's for your reference system. So you have a display unit for that. You have your control panel for audio. So that's going to be for audio signals coming from the receivers, okay, like your ILS, what I mentioned earlier, okay, your VOR, your ADF. So anything being received, that's going to be controlled by the audio control panel. It's also important to be aware of what standby equipment that you have, and so with what we have here, like there's a compass, by the way. So that's one example. You have a compass. You also have an altimeter. Okay, and both of those are located on the center instrument panel. That's a test question. Okay, so where are the standby instruments located? They're located on the center instrument panel. Okay, so let's talk about the standby altimeter. Here you've got 4 adjustable bugs that are used to set the reference altitudes, and because altimeters do altitude, right? There's 2 drums, so as far as the display goes, you're gonna, it's made up of 2 drums. There's one that's displaying in 10,000s, and the other in thousands of feet. Okay, there's 3 zeros are fixed there. So for when the altitude's, let's say, below 10,000 feet, then what's going to happen is the left drum is going to show black with white stripes. Okay, and if the altitude is below sea level, then you're going to see orange and white stripes. So below sea level is orange with the stripes, and below 10,000 feet, but not below sea level, is going to be, the black color. Okay, so, and just to understand the kind of the conversion here, the revolution measurement, okay, units of measure. One revolution of that pointer is equivalent to 1,000 feet. Just so you know how the scale goes. Okay. There's also a baro correction that shows up on a counter in hectopascals or millibars. These are just units of measure, okay, for this type of application, or in inches of mercury, depending on the type of indicator that might be there. So, that's just a possibility. It just depends on the configuration of the aircraft as far as the instruments goes in this particular case with standby instruments. Okay, so if it turns out to be mercury based, then that's what you're going to have as a graduation there in hectopascals or your millibars. There's also a knob that you can adjust the baro setting for. That's what you're going to use that for. And as far as its range on that knob is going to be between 750 to 1,050 hectopascals. Okay, or if you want to measure it in mercury, we're doing inches, so that's 22.25 to 31 inches of mercury. Okay, so that's your standby altimeter, okay, located on the center instrument panel, like I mentioned before. And, now let's go to, talking about remember I said there was a standby compass. So, standby compass, this here is located, I mentioned about standby instruments, being on the center instrument panel in general. The standby compass is located on the top of the windshield center post. Okay, it's normally just kept stowed away. Okay, so just, no, that's the case with this one. There's a non-magnetic lamp assembly that provides the lighting up of the compass card. It also controls this, or lights up, the switch. Okay, that's going to say standby compass. Okay, and that's located on the overhead panel. Okay, so then you also have a standby horizon that's located on the center instrument panel. So there's that other one that's located on the center instrument panel. The compass is located on the windshield center post. Okay, so let's a little bit on the standby horizon. There's an aircraft symbol in the indicator that's fixed, and what it's used for is a pitch pointer against the pitch drum. Okay, pitch drum is divided into different sections that's separated by the reference horizon. It's just the way it's designed. Again, this is a navigation tool. Okay, all right, so that's on some of the standby instruments. And then I just want to go a little bit into the weather radar. I know I mentioned that just briefly earlier, just so you had some just knowing that that's part of the navigation system is your weather radar. Okay, so what do we have here? What do we need to know about this? With your weather radar system, you've got different things on here, and there's a diagram that will help you kind of see a little bit better. But you have antennas. This is part of the multi-mode. Okay, I'm going to go over the multi-mode receiver system and where it's located. Remember, probably from one of the other topics we covered, I did a walkabout basically, and I said, okay, what's at the nose of the airplane, right? Well, you're going to have, that's where your radome is located. Okay, so your radome is wet. Okay, what do we have there near the radome? Okay, that's going to be where your localizer and your glide slope antennas are. So those are actually under the radome. Okay, so you have that, and you have also just the, of course, any avionics equipment are located in the avionics compartment, and that's where the MMRs are located. Okay, the multi mode receivers. That's where they're located. Okay, and your weather radar. Okay, so your weather radar. There's a weather radar system, and as far as the kind, you probably not too important to know, but it's an X-band kind, and this is just going to be able, remember I said before, is detect and, basically tell about the precipitation. What is the condition of the atmosphere, so that's going to affect things with the aircraft. So it's gonna sense those things, and there's antenna scanning in order to pick those things up. So basically what it's doing is detecting any turbulence areas that may be around that are being caused by precipitation pockets around in the air, in the atmosphere, and then also the terrain, just by radar beam. So it's going to be sensing where, kind of the, I should say, the gradations and valleys, etc., of the terrain itself. So that's what it's doing. Also, it's associated with the ADARU. Okay, remember I mentioned there were 3 air data inertial reference units that make up the ADARs, that make up the reference system. And so this particular weather radar system is associated to these units, as well as its association to the electronic instrument system. Okay, and that's so that it can generate distance scales, okay, and also show radar images. It needs that connection with those systems. Okay, so where can you find the transceiver for the weather radar? That's located in the forward avionics compartment. They're in the obviously our electronic equipment is located in the avionics compartment. In this particular case, it is located in the forward part of it. Okay, now the control unit for the weather radar. Okay, so the transceiver is in the avionics compartment. The weather radar control unit is on the aft left side of the pedestal. That's where you'll find that control unit. And the antenna, of course, is located under the radome. Okay. All right, so that's on the weather radar system. Now, there's different components to the weather radar system. You've got a control unit like the one I just mentioned to you that's on the left, on the aft side left of the pedestal. You also have an antenna drive, and then of course an antenna, and then you have a transceiver mounting tray, as well as the transceiver itself. Okay, so this image is going to be showing on the 2 navigation displays, on your 2 NDs, right? The one on captain's side, and then the one on first officers. So you have that there, and of course those NDs are going to be connected to what? So we can connected to the management computers. Okay, you've got 3 display management computers involved here, and so those navigation displays are going straight to those computers. Okay, and also to the captain and first officer's control sections of the FCUs. Okay, when you have the ground proximity warning system in operation, then what's going to happen with the weather radar image? Okay, remember we're showing it on ND. It's going to be replaced by the terrain image. Okay, because if there's a warning that needs to be shared with captain and first officers, it's going to be showing on those NDs, and so it's going to be replacing whatever was there showing. All right, so kind of just different things to look for in this weather radar display or images. If there's any disturbance to the atmosphere because of precipitation, then those are going to show on the NDs with different colors. So for example, your precipitation rates are going to be showing in black, green, yellow, red. Then you also have turbulence areas. Those are going to show in a magenta color. And there's, of course, if there's no detection of anything, well, nothing's going to show, okay? So just kind of keep that in mind just for knowledge. Magenta means that you're going to have turbulence areas. Precipitation is going to be, depending on the quantity of the precipitation rates, you're going to have it in yellow, red, green, or black. Your antenna, okay, what's its range of scanning? Okay, so the antenna, it's going to be scanning 180 degrees of sector in azimuth, and it also has a pitch coverage of plus or minus 15 degrees. Okay, so what's the antenna's range of scanning? It's 180 degrees, okay, in azimuth. And if you don't understand that, and this is all part of this, but if you don't understand about azimuth, we're going to cover, actually, Rick can help you out with a lot of the things too here, even we're talking about electricity, like electrical power, and we're talking about capacitances and just inductance, things like that, and they're referring to that, and you don't understand what that means and you want to know, email, say, hey, I want to know more about that. Typically, you're not going to be interested in it, but, you just want to get to, where's the troubleshooting page and, kind of some locations of some of the components, obviously, if you're not familiar with the Airbus in particular. So just letting you know, kind of a side note, if you are interested in learning more, we do have information, and we're going to put some, just check out some videos and keep, checking back, because we want to continue to add to our video information library. Okay, so additional stuff here. You've got the weather radar as a navigation aid, of course, because when you have it in the mapping mode, obviously it's going to be identifying any changes in the ground map. Like if there's anything, if the aircraft's going over a lake or a mountain, an island, or whatever is underneath. So it's definitely capturing that. Now, controlling the weather radar, how is it being controlled? Remember I said there's a control unit. Okay, so you've got the control on the NDs that happens through the switches. Okay, and those are located on captains and first officers' EFIS control sections, of the FCU. Okay, so you've got different things that you'll see on there when you're operating the controls. There's SYS, okay, your system switch for system on and off, okay, and then of course you have your mode, okay, MODE selector switch, and that enables selections of WX, okay, your weather plus turbulence, or your TURB for turbulence or map, okay, anything on the ground. A tilt selector switch, that's for the antenna elevation. That's for controlling the antenna elevations, your tilt, TILT selector switch. Okay, so there's that switch. You have your mode selector switch. You also have your sys switch, okay, for system. Okay, then you also have your gain potentiometer, and that's for adjusting the transceiver gain. That's done manually, right? You also have your GND, CLTR, SPRS switch. Okay, so for that's your ground, and that's for the clutter suppression. That's what that's abbreviated for. So you're selecting ground clutter suppression. Okay, so what else on controls do we have? There's also the scale selector switch. Okay, so you have obviously a scale, which means you have different choices on here. You've got 10, 20, 40, you've got 80, 160, just different operation range, and these are all in nautical miles. NM, by the way, is the abbreviation unit to measure for nautical miles. That'll show up on the display, okay, for the image on the NDs. Okay. All right, so didn't want to go too quickly. I wanted to make sure I was making sure you just got it in your head. Just again, this is just familiarity. Obviously, seeing test questions or seeing the questions in handouts, and also just taking notes, and any other information that we can provide you is just little, kind of a highlights, if you will, help. Okay, so that's all on the weather radar controls, and then also in describing the weather radar. And now I want to go into a little bit on the weather radar indication. Okay, and then we'll look at any faults that we can expect. If there is a fault, what are we going to see? Okay, how is it going to isolate the faults here? What kind of faults are we talking about?